Hello everyone, welcome to the next lecture of our blockchains course. So in this lecture, we are actually going to go much more deeper into Hyperledger Fabric itself, looking at some of the identity management and membership aspects of Hyperledger Fabric. So this is going to be delving into some of the primitives that Hyperledger Fabric uses for some of the security and privacy properties that we want to achieve for our enterprise applications. Getting into the details now. So first of all, I think an important notion to understand is the notion of organization. In the enterprise world, you can think of these organizations as legal entities. So they all have a business that they are running. And we can recognize these organizations with identities that they are provided on the blockchain network. So each organization, for instance, it will have a membership service provider for the identities for the users belonging to that organization. So we have users of that organization. The organization can also define a set of administrators. So these administrators will be the ones who are running peers, maybe the ones who are helping these peers join the channel. They might be installing chain code on behalf of these peers, or they might also be executing ordering services. So what are the different components? So you have administrators and users, and the organization could be running one or more peers in the network. Some might be endorsing peers, some might be only committing peers, and optionally they can also run ordering nodes, right, for one or more channels. So each organization can participate in one or more channels in the blockchain network, and all that information is captured in the network itself. So each channel configuration in the Genesis block or in subsequent blocks where it gets modified, the organization information is also captured there. The network can include, of course, many organizations, and it could be a consortium. Okay, so let's say a group of 10 banks might form a consortium, and each bank can be represented as an organization on the network. So this is a boundary that we define in terms of identity, and these identities of these organizations are separated out using the membership service provider. So typically there will be one membership service provider per organization, where although it's possible to have one MSP serving multiple organizations, and it's also possible for one organization to have multiple MSPs, those are possible, but the recommended use is to have one MSP per organization. And like I mentioned, each organization is going to have an ID on the blockchain. So here's an example of a consortium network. There are 3 organizations in this consortium. Organization 1 and 3 are the ones that are running peers. Organization 2 provides only the ordering service in this example. So organization 1 is running 2 peers, shown here. Organization 3 is also running 2 peers. Each of these organizations have their admin and one or more users. Likewise, org3 also has the same. And there are chain codes or smart contracts deployed on the channel. So in this network, there are actually 2 channels, the blue and the red. And there are chain codes that are deployed on both the channels. So the A and B on the blue network and Y and Z on the red network. Both of them are using the same ordering service that org2 is running, and that org2 has an administrator who is in charge of running this ordering service. Right? And the ordering service is going to maintain 2 chains of blocks. One blockchain is going to be for the blue channel, one for the red channel. And the transactions on these 2, as I mentioned, are going to be kept separate. So going to the membership service provider, what that means is there is a distributed network with a set of identities, and there are identities that are provided for every concept or entity in the network. So there are identities for peers, there are identities for the orderers. So the ordering service is here and the peer is here. Each of them are issued identities. They will use these identities to communicate with each other. There are client applications, and we provide identities to the client applications also. So there could be a peer. For the peer, there will be an admin. For the orderer, there will be an admin. So there are a bunch of administrators who are managing this network themselves, and those administrators have identities. And these identities are issued by some certificate authority. So this can be the Fabric certificate authority that is issuing these identities, or it could be an external certificate authority that is issuing these identities. So as long as the root CA is recognized by the network, you can bring in any certificate authority of your choice. Now, what are the benefits of having all of these identities, right? What sort of properties are we providing? Of course, there is authentication. So every time a user transacts on the blockchain, they are authenticating themselves by signing the transaction. And this sign is verified by the peer or any other entity in the network. So the peer is going to validate the signature provided by the user. So that's the validation part. So if you are not a registered user on the network, you cannot perform transactions, or you cannot see what the blockchain state is. You cannot read that set of channels. You can't see what channels are available. So none of that information will be available to you. You have to be authenticated on the network to transact on the network. It also has the ability for you to sign information. For instance, the user will sign transactions, send it to the peer. The peer will execute the transaction, and when it endorses, it is actually going to sign the endorsement. Likewise, the ordering service, when it creates a block and sends it to the peers, each block is going to be signed by the ordering service. So you can validate that all of this is coming from the authorized entity to perform that thing. So if someone else, let's say one of the peers, tries to maliciously sign a block and send it, all the other peers will know that this did not come from the ordering service. It came from somebody else. So it will reject that message. So signing and issuance are all possible because of the security framework that we have through the membership service provider. The MSP can support different crypto standards. This is meant as a pluggable interface, and the main reason for this is that different applications might need different security properties that might be provided by different CAs, different crypto standards. So all of that becomes pluggable. And it's also the fact that security itself as a domain, as a field of knowledge, has been growing so rapidly that over a few years you might find better security standards, better ways of securing our systems, and we want to be able to allow that. Right? So all of these are provided as pluggable features. And a network can have multiple MSPs. Like I mentioned, the recommended way is to have one MSP per organization. So based on the number of organizations you have, you might have that many MSPs in the network. And there is also TLS, which is transport layer security. And this is used for encrypting all the communications across the network. So the peers amongst themselves when they communicate, peers to order communication, user to the peer communication, between peers and chain codes that they run, that communication, all of it is secured through TLS. So what is really this TLS? It's a cryptographic protocol. It's actually a standard that secures all communications over a computer network. So it provides two important properties. It provides the notion of privacy and the notion of data integrity. So what do we mean by privacy is that only a certain set of nodes or certain set of people should be able to see what that communication is. So that's the notion of privacy. The data integrity is when a node sends a communication to another node, the recipient should get the same data as was sent by the sender. Right? So that data should not get changed over the course of the communication. So that's the data integrity. So how is this achieved? TLS uses symmetric cryptography to encrypt the data that is transmitted. So because of this encryption, anyone who does not have this key will not be able to decrypt this message and will not be able to know what this communication was about. So that provides privacy. So only the participants who hold the key. Typically it's just two entities, A sending a message to B, that communication is encrypted, and because of the fact that only A and B have this key, only they will know what the contents of this communication are, what contents of this communication is. So that's the privacy part of it. And it uses public key cryptography to authenticate the identities of the communicating parties. So this provides a part of the data integrity to say that only A is sending this message and B can verify the fact that it was actually A that sent it. And that is achieved using public key cryptography. And there are message integrity checks that are included to prevent loss or alteration of the data. So let's say the communication between A and B, there might be packet loss, there might be an attacker trying to manipulate this message in the middle in the network. So to prevent all of that, there is a message integrity check. So think of it as the equivalent of like a hash or a checksum. So you can check that the message that you received was exactly what the message that was sent. So that's the message integrity check, and all of this together forms the protocol itself. And every communication in Fabric between client and peer, between peer and peer, peer and orderer, between orderers themselves, all of this is secured using TLS. So it provides this privacy and data integrity for all communications. So getting a little more into what these identities are. So I told you that every user in the network is going to be issued an identity, an enrollment certificate. Right? The enrollment certificate has two parts. One is it has a private key, and this private key has to be private to that user. Nobody else should know what that private key is. And the user will be using that private key to digitally sign transactions they are submitting onto the network. So that's the private key, and it's stored in a secure key store. The second part of the identity is a sign cert, which is a public X509 certificate in the Fabric implementation. But like I mentioned, other crypto standards can also be used. This public certificate will include is your public key. So everyone will know using this public key, they'll be able to validate whether it was indeed this user who signed that transaction. So the public key is used for that validation. And it also includes certain attributes that the certificate authority might provide to the user. For instance, some of the attributes might be to say that this user, let's say for me, let's say I have a digital certificate. My public certificate will include the fact that maybe I belong to organization IBM Research. It might have other attributes saying I'm actually a researcher, and it might have certain authorizations, certain roles that I have on the network. For instance, if this is a supply chain blockchain network, then it might even have a role that says I am an exporter in this network. So those sorts of attributes can also be embedded within the certificate, and we can use those attributes to authorize transactions on the network. So the smart contract can include aspects saying only a user who is an exporter, who has an attribute called exporter, will be allowed to perform this transaction. So anyone else, let's say someone else who is let's say a carrier or a freight forwarder in this network, will not be able to perform that particular transaction, like invoking that particular smart contract function. So all those capabilities are then possible through attributes embedded in your certificate. And it also optionally includes your TLS credentials. And that is important for, let's say, the peer. When it's for the peer identity, the peer needs a TLS credential for it to be communicating with other peers and orderers in the network. And all of this can be backed by a hardware security module where these keys are securely stored. And the HSM can be used it's a hardware module, and that can be used to sign transactions without anyone else, any other component in your system getting access to the private keys. Right? So that's the user identity itself. The admin identity is very similar in concept to the user identity. And each administrator has a local MSP to store their identity. So every admin is connected to a local MSP. And just as the user identity, it has a private key that is stored in a key store, and it has a public X509 certificate that forms its sign cert. And again, it could have TLS credentials, and it could be using a hardware security module to store and sign transactions. So what do the peer and orderer identities look like? Again, it's similar. It has a private key and a public X509 certificate. It has a local MSP attached to the peer, which holds these identities. And in addition, the peer and MSPs can identify authorized administrators. So it could have one or more administrators for this peer, and the admin certs are also included. So for instance, an organization who is running the peer can designate one of its users as an administrator, and that administrator will be included in the admin certs. And there are specific functions that only the administrator can do. For instance, joining a peer to a particular channel can only be performed by that administrator user. If a regular user who is not an administrator tries to perform that transaction, it will be denied by the network. And the admins, apart from that, it can also store the public certificates of CAs that it will recognize. So this is needed to recognize, let's say the user certificate was issued by a certificate authority, a particular certificate authority, then that user certificate is actually signed by the CA. So we need the public certificate of that CA to be able to validate users who are connecting to this peer. So that's part of the CA certs. And there are also certification revocation lists. So these are CRLs. And these revocation is important to, over a period of time, manage which are legitimate users, which are not. And even for a legitimate user, it is advisable to change your certificates every now and then for security purposes. So maybe you hold your certificate for a certain length of time, and then you will revoke that certificate and have a new certificate issued for the same user. Right? For security purposes, it's advisable to rotate your certificates. So you can have certification revocation lists to say which certificates have been revoked and should no longer be admissible on the blockchain. And peers and orderers also receive the channel MSP information. So the channel also has a MSP. The peers and orderers will know which channels they are connected to. So that is also happening through the MSP in a secure manner. Again, the peer and orderer identities can be backed by a HSM. Now, what does the channel MSP look like? So, like I mentioned, every concept in the Hyperledger Fabric is associated with an MSP. So, the channel MSP has information about which peers and which orderers can join that channel. And this can be dynamic. So, it's possible that some peers join the channel at a later point of time, other peers might leave the channel. All that is dynamically configured in the channel MSP. And the channel MSP is also queryable. So a new peer joining the channel can query the channel MSP to find out which other peers are participating in this channel. It also determines which client applications can connect to this channel and can perform transactions on this channel. It also stores all the configuration blocks in the ledger. So like I mentioned, any new peers joining the channel, any orderers joining the channel are all configured as transactions on the blockchain. And the channel MSP stores that information as well. What is the latest channel configuration will be part of it. The channel MSP also includes administrators. So who are the administrators for this channel? For instance, it could be multiple organizations administrators who are recognized as administrators for a channel. Right? So they might determine when to admit a new peer and other changes in the channel configuration. Of course, there are again the certificate authorities who are recognized by this channel for authenticating the identities. They are all signed by the CA. So you need the CA's public certificate for validating that. And again, you could have certification revocation lists like before. So it's an important thing here is that it does not include any private keys for identity. So the channel information is all public information of who are the administrators, who are the CAs, what are the peers and orderers as part of this channel. It does not have any private information. So how does a new user enrollment work? Registration and enrollment. So let's say I am a new user on this network. So I'm part of some organization. So there is I need to talk to some admin. Maybe my organization is already part of this network. They have an administrator, and that administrator has to register. So first the administrator registers. When the peer joins the network itself, the administrator has to be registered, and subsequently it will only be the administrator who can register new users from that organization. The administrator calls the register function. It will with a particular identity, and it'll say, I want to register this new user with this blockchain. So it contacts the CA, and the CA returns a particular secret. So then the administrator sends this enrollment ID and the secret to the user. So this forms the identity, the long-term identity that the user will be using to transact on the blockchain. Once it has received these credentials, so the secret also includes the certificate that they need to use. Once they've received these credentials, they will then use that secret to enroll with the Fabric CA, and that returns the enrollment certificate for them. So that will be the long-term certificate that the user will use to transact on the blockchain. To just recap, administrator has to register the user. The administrator then sends the enrollment ID and secret to the user. The user then contacts the CA with that enroll ID and secret to obtain an enrollment certificate, and it can then use that enrollment certificate for transacting on the blockchain. So now once you've got the enrollment certificate, you can use that for transaction signing. All the transactions submitted on the blockchain have to be signed by permissioned users on the network, and those signatures are validated. Users sign transactions with their private key. That private key will be part of the local MSP of the client. The peer will have the public key, and they'll be able to validate the signature. So the user is going to sign the proposal, and the peer will sign the response. will validate the signature and it will sign the response. So that is the three here. So the user signed the proposal, submitted to the peer. Peer executed, before executing the transaction, it's going to validate the client signature. And when it creates a response to be sent to the client application, it's going to sign the response with the peer's private key. So then the client application can validate the peer signature to make sure the legitimate peer has signed this. It will then sign the entire endorsed transaction. It might do this with multiple peers. It will collect all the signatures and it will then sign the transaction to be sent to the ordering service. The ordering service will validate the client signature again, and it is going to, when it sends the block to the peer, it is going to sign the block. That is the 7 here. The peer can again verify that it was indeed the orderer that signed and sent the block to the peer, and it will validate that orderer signature, and only then it will validate the transactions and commit the transaction. So at every step, every communication, you will see that there is a signature and a validation performed on the blockchain. So this provides for secure communication across all the entities in the blockchain network. With that, I hope you have a good sense of how the membership service provider works, how the secure communications work, how signing of transactions and verification of transactions work across the network. So there is a good set of reading material. Again, hope you go through some of these. If you have not seen transport layer security before, I would encourage you to read the Wikipedia article. It gives you a good overview. This is a standard practice in the internet today and for any kind of secure communications. So I would encourage you to read that. So even beyond just knowing about blockchain, it will help you learn some of these concepts. Again, the concept of digital identity is something much beyond just blockchain. It's used in multiple systems today. So you can read up again from Wikipedia. There are very good articles on what digital identity is. Using the digital identity, you can have digital signatures. Again, an excellent Wikipedia article on that. I would encourage you to read that for sure. And a specific implementation of these identities and signatures is the X509 standard for certificates. And again, there's good reading material on that. So with that, I hope you get a good overview of how we've used traditional security concepts. Although I say traditional, they are the most cutting edge technology that we have today for security, and how that is used to secure communication and transactions on Hyperledger Fabric. So thanks a lot for your time. So we'll see you in the next lecture.